You're probably using a computer to watch this right now, whether it's on your phone or your desk, and it all just works. But have you ever really stopped to think about what's going on under the hood? It feels like magic, but it's not. It's actually a beautifully logical system. So today, we're going to pull back the curtain and figure out how a computer actually thinks.
So yeah, that's the big question, right? How does this box of metal and plastic take a click or a tap and turn it into, well, anything? A movie, a message to a friend, this video. It seems impossibly complicated, but the answer starts with a really simple idea. And that idea is this. A computer isn't one thing, it's a system. Just like a city's subway system or your own body's circulatory system, it's a bunch of different parts all working together to get a job done. And pretty much every system, no matter how complex it seems, follows one simple fundamental pattern.
And here it is. This is the blueprint for basically everything. Input, process, output. You give it some information, the system does something to that information, and then it gives you back a result. I know it sounds almost too simple, but this little three-step dance is the absolute heart of how a computer thinks. So let's break down the parts that make this whole dance happen, starting with the physical stuff.
Okay, first up, the hardware. If the computer is a system, then the hardware is its body. All the tangible parts that are actually doing the physical work. Hardware is everything you can see and touch. The monitor, the keyboard, the mouse, all the stuff you could, stub your toe on. And every single one of these pieces has a very specific job to do in that input, process, output model we just talked about. So let's start at the beginning. Step 1, input. How do we get our ideas and commands into the machine? Well, we use input devices. They're basically the computer's senses, acting as a bridge from our world into the digital one.
And you use these all the time without even thinking about it. Your keyboard turns your button presses into characters. Your mouse turns your hand movements into a cursor on the screen. A microphone turns the sound waves of your voice into a digital file. Each one is just a translator for the computer.
All right, let's jump to the other end of the line. Step 3, output. So the computer's done its thinking. Now what? How does it tell us the answer? It uses output devices. This is how the system talks back to us. The monitor is the most obvious one, right? It turns digital data back into pixels we can see. But so are your headphones. They turn data back into sound waves. A printer even turns that data back into a physical object. They're all translators, just going in the opposite direction, turning the computer's language back into something we can understand. Now, of course, it's not always that simple. Some hardware can wear a couple of different hats. Think about the touchscreen on your phone. It's an input device when you tap it, but it's also an output device because it's showing you what's happening. And then you've got storage, like a hard drive, which is all about holding on to information for later. They're all key parts of the computer's body.
Okay, so we've got input and we've got output. We have the computer's senses and its voice. But what about that all-important middle step, the processing? For that, we've got to look inside the computer's brain.
This, right here, is where the real magic happens. The processor, also called the CPU, is what takes all that raw data from the keyboard or mouse and actually turns it into something useful. It is the engine driving this whole operation, and it's made up of 3 key parts that work together perfectly.
First up, you've got the control unit, or the CU. The best way to think about the CU is as the traffic cop of the whole system. It doesn't do the math itself, but it reads the instructions, line by line, and tells all the other components what to do, where to go, and when to do it. It keeps everything moving and makes sure there are no crashes. Next up is the arithmetic and logic unit, the ALU. Now this is the part that does the actual thinking. If the control unit is the manager, the ALU is the brilliant mathematician in the back room doing all the hard work. Every single thing your computer does, from opening a file to rendering a video, gets broken down into millions of tiny little math problems or logic questions, and the ALU is what solves them at incredible speeds. And finally, you have registers. Okay, so if the ALU is the mathematician, the registers are its personal sticky notes. They are tiny, super fast little bits of memory that hold the exact number and the exact instruction that the ALU is working on right this second. It's like having the numbers you need to add written right on your hand. That instant access is what makes the whole processor so unbelievably fast. So, let's recap. We've got the body, that's the hardware, and we've got the brain, the processor. But a body and a brain with no instructions, no thoughts, well, they can't do anything, can they? And that's where the last piece of this puzzle comes in. This is the computer's soul, the software.
At its core, software is just a list of instructions that tells the hardware what to do. And that software is usually split into two big categories that do very different jobs. You've got system software and you've got application software.
So, what's the difference? Well, think of it like building a house. The system software is the foundation. The electrical wiring, the plumbing, it's all the crucial behind-the-scenes stuff that the house absolutely cannot function without. Then you have application software. That's the furniture, the paint on the walls, the TV. It's all the stuff you add on top to actually make the house useful and do the things you want to do. Your operating system, so Windows, Mac OS, Android, whatever you use, is the biggest, most important piece of system software. It manages everything. But there's other stuff too, like the basic instructions your computer needs just to turn on, or the little driver programs that let it talk to your printer. It's all the essential stuff you never really see. And on the other side, you have the applications, or apps. These are the programs you actually interact with every single day. Your web browser, your music player, the game you're playing, they're the specific tools that you choose to install on top of that system foundation to get a particular job done.
All right, so there we have it. We've got the hardware body, the processing brain, and the software soul. Let's put all of these pieces together now and look at the complete picture of how a computer really thinks.
This quote really says it all, doesn't it? It's an organization. Everything works together. So let's trace that loop one more time. You give it input using the hardware, the body. The software, the soul, tells the processor, the brain, what to do with that input. The brain processes it, and finally, the brain sends the output back through the hardware for you to see or hear. Body, brain, soul.
Thank you for watching this video. If you enjoyed it, please hit the like button and the bell notification icon. Thank you for watching this video. If you enjoyed it, please hit the like button and the bell notification icon.